For domain and range, we're going to talk about relations and functions where we have to, again, determine whether a relation is a function or not. So, but for now, according to the definition of relation is a set of ordered pairs. So I'm going to show you a couple of examples about relations, and also for the function, in a set of ordered pairs in which each element has only one y element associated with it. Now, how will you know if a relation is a function or not? Here we go. So here, right now, I want you to pay attention here because right now we have 1, 2, 3, 4. Right now we have 4 sets. Right now we have 4 sets. We have 4 relations here. But we're going to identify if each relation is a function or not. Now, how do we know if a relation is a function or not? So here we go. Let's start with set S. For set S, first is we have to identify the values of the x values, the domain. Now, let's go ahead and identify the x values in our ordered pair. So here for set S, we have 1, 2, 3, 4 ordered pairs. Same thing with the rest of the sets. So for S side, what do you call it? For set S, we have 5, 6, -5, and 2. So here, because we got 5, 6, -5, and 2, and none of the domain is repeated, then we can say it's a function. Once again, a relation is a function when the domain, when the x values are not repeated. Okay? Let's take a look at letter, it is a function. Again, because the x values are not repeated. How about -5, 9, 5, and -2? So let's check. The x values are not repeated. We got -5, 9, 5, and -2. So again, it is a function. Now, how about set U? Let's underline the x's. So we have 9, 6, -5, and 3. Again, none of the x values, none of the domain, okay, is repeated. So that's why we can say that it is a function. So the last one. 7, 6, 7, 2. Oops. Here we got 7 and 7. Again, 7 and 7 are repeated. So therefore, it is not a function. Now, what's the reason again? What's the reason why set V or relation V is not a function? Because the domain is repeated. One of the values of the domain, or I would say, two of the x values of domain are repeated. So we have 7 and 7. That's it. So that's how will you identify if a relation is a function or not. Once again, to identify if it's a function, look at the x values. We don't really care about the y values. If the y values are repeated, we don't care. Okay, what we care this time are just the x values. If the x values are repeated, it is not a function. So here they're not repeated, that's why it's a function. Not repeated, function. Not repeated, function. For the last one, we got 7 and 7. They're repeated. They are both x values. That's why set V is not a function. So relation V is not a function. Now, we're going to take a look at identifying a relation, whether it's a function or not, given a graph. But using the vertical line test, a graph is a function if the vertical line intersects the graph at exactly one point. So, for example, here, First is using the vertical line test. That means we just have to draw a vertical line, and if the vertical line crosses the graph at exactly one point in any part of the graph, then it is a function. So here, this graph is crossing this vertical line is crossing the graph at one point. How about this part? Crossing the graph at one point. How about in the middle? Crossing the graph at one point. That's why it is a function. Now how about this one? Oops. This vertical line is crossing the graph at 1, 2, 3. It's more than 1. So that's why it is not a function. Okay, how about here? Oops. We got 1 and 2. So using the vertical line test, if the vertical line is crossing the graph at more than 1, then it is not a function. Okay? How about here? Oh, not bad, not bad. Okay. So 1, that means it is a function. Now, let's take a look at this one. If you draw a vertical line in the middle, yes, it is a function. Here, it is a function because the graph is crossing the vertical line is crossing the graph at exactly one point. But if you draw a line from here, a vertical line, it's going to cross infinite number of points on this side. Same thing if you draw a line all the way here, and it's going to pass, that vertical line is going to pass this side in infinite number of points. That's why I would consider this as not function. It looks like it's a function when you draw a vertical line in the middle, but if you draw vertical lines on the sides, then it's not a function. So again, given the graph, just use the vertical line. Given the ordered pairs, look at the x values, look at the domain. Now, a while ago, I've been saying the word domain. When we talk about domain, it's actually easy because we're just talking about the values of the x values of the ordered pairs, while the other side of it is range. So for x values, we're talking about domain. So for the y values, we're going to talk about range. So here we go. Let's try this. Okay. So first, before we answer if it's a function or not, let's underline the x values first. Now, are the x values repeated? So we got 5, 6, -5. So no. So that's why yes, it is a function. Domain. Again, for domain, we're just going to talk about all the x values. So we got 5, 6, -5. So these are the x values, and we call them domain. And the y values are 3, 4, 9, and -1. 3, 4, 9, and -1. Again, for domain, we have the x values. For range, we have the y values. Now, I want you to use a method and try this part now on your own for 10 seconds. Okay, so first underline your, well actually it's the same thing anyway, so same question. So first underline and then same questions. I didn't realize that we have the same question here. Okay, now how will you identify the domain given the graph? Now, it's easy to identify the domain and range given the ordered pairs. But given the graph, it's a little bit interesting. It's a little bit confusing. Okay. Now, when we talk about domain, we're talking about all the values from the left side, which are the negative values of the x-axis, and all the values on the right side, which are the positive values of x. So for domain, we're talking about left and then right. Left values and then right. We're talking about the x values, because we're talking about domain. So if you're talking about domain, we're talking about the x values. Now, as you can see, the graph might be opening down, but as it opens down, it also opens to all the way to the left and all the way to the right. So I would say that if the graph is opening up or down, and as long as it's opening to the left and to the right, my domain is going to be... Now be careful, because a lot of students are confused about reading this. Some of them would say it's a T and an R. So if you draw that, you just have to draw like those two lines and then an R. And that means we're talking about all real numbers. Now, what do we mean by all real numbers? Because the graph is going all the way to the left and all the way to the right. That means the graph is going all the way to the left, which means the graph is using all the negative numbers to the left and all the positive numbers to the right, and also the number on the zero. So that means our domain are all the numbers, all the negative numbers, including zero, with the positive numbers. That's why domain is all real numbers. Okay? Let's take a look at domain of this one. Again, for domain, we're talking about going to the left and going to the right. Here, how do you know the graph is going? The graph continues to grow. It's because of the arrows. So here we got two arrows. That means it's going to go down, and at the same time, it's going to go to the left side, with also the other side to the left and right. Okay, so here we go. Now, does this graph goes all the way to the left and goes all the way to the right? The answer is no. Now, I want you to take a look at these two graphs. What do you think is the difference why this does not go all the way to the left and go to the and right? Because this line does not have arrows. So that means this line starts at, if we're talking about from left to the right, it starts from, I believe that's -6. So it starts from -6 to 5. -6 to 5. Now, how will we write this in mathematics, in algebra? Okay, so that means your numbers are just from -6 to 5, which is -6 there and then 5 there. So this will be the other way around. So x is greater than or equal to -6, but less than or equal to 5. So again, it starts from -6 to 5. So x is greater than -6, but less than or equal to 5 because of that. Now let's take a look at the range. When we talk about the range, again, students, when we talk about the range, we're talking about the y values. So for here, for the domain, we were talking about going left and right. That means for the range, we're going to talk about going up and going down. Now, is this graph going up? No, because the arrows are going down, so that means we can say that the graph is going down. But wait, where does the graph started? Where is the maximum point of the graph? So the maximum point of the graph is actually 5. So that means we have y is, because the graph is going down, so I would say y is less than or equal to 5. Less than or equal because the graph is going down. Now, how about here? Okay. So again, for domain, we were talking about going left and right. This time for range, we are talking about going up or going down. Now, Does the graph going up or going down? No. But I believe that the highest point, or I would say maximum point, is it starts at 3 of the y. Starts at 3. 2, or I would say, let's start from the bottom first. Start from the bottom. Lowest point is negative 4, 2, 5. So when I write it, I'm just going to use this notation, but using the instead of using x, because we're talking about the range, then I'm just going to use y. So I would have negative 4 is, there you go, and 5. Now to read this is y is greater than or equal to negative 4, and y is less than or equal to positive. My bad, I think it's 3. Let's change it to 3. Okay. So, to 3. Okay, let me know if you have questions. That's about it.